In this lesson, we're going to review area. If you refer to page 190 in your textbook, you will see some area formulas that you should by now be familiar with, and those may come in handy throughout this lesson and also while doing the homework after today's lesson. The first couple of examples here require us to find the area of some slightly complex figures. The first one appears to be sort of a rectangle with a piece cut out of it. And so what I would like you to do is sort of envision this as a completed rectangle, but we have cut a triangle out of that rectangle. So in other words, the strategy we would like to use here to find the area is to find the area of the completed rectangle, and from that we're going to subtract the area of the triangle at the top. Now the area of the rectangle, of course, would be length times width, so 10 times 13. And for the area of the triangle, we recall that the area of a triangle is given by the formula base times height divided by 2. But if we look at the diagram, the base of this triangle is not given. Be careful not to assume that those two sides have the same length. And in order to find the length of side x, we're going to have to use the Pythagorean theorem, which of course we can do because this is a right-angled triangle as indicated in your picture. What we do know about this triangle is that the length of the hypotenuse is going to be the same as the bottom of this rectangle, which is 13 meters. So off to the side, let's use the Pythagorean theorem to find the length of side x. We do know that x squared plus 9.5 squared is equal to 13 squared. If we simplify that, it leads to x squared plus 90.25 equals 169. Subtract 90.25 from both sides, so that gives us x squared equals 78.75, and taking the square root of both sides tells us that x is approximately 8.9. So the base of this triangle is 8.9. Now if we go back to our formula here, we can figure out the area of this triangle as 8.9 times 9.5 divided by 2. Okay, 10 times 13 is 130. And with your calculator, if you multiply 8.9 times 9.5 divided by 2, I believe you will get 42.275. And therefore, the area of this figure is 87.7 approximately meters squared. Okay, now the next example appears to be a trapezoid with a semicircle on top. So that's the strategy we're going to use for finding the area of this one. We are going to find the area of the semicircle, and we're going to add to that the area of the trapezoid at the bottom. The area of a circle, a full circle that is given by the formula A equals pi r squared. So in the case of this example, the radius is 6. So if this were a full circle, the area would be given by pi times 6 squared. Since this is a semicircle, we're just going to divide that by 2. And the area of the trapezoid at the bottom can be found by using the area formula that you may be less familiar with for trapezoids, which is A equals H times A plus B divided by 2. And in that formula, A and B are the horizontal side lengths, as I've indicated here for you. Okay, and the height would be given as so. Now, if we look at your picture, we do know that the radius of this circle is 6. Okay, so that would be the distance from here to here, will be 6 centimeters. It's not the easiest to read. There we go. And the height from top to bottom, although this diagram is a bit misleading, I think this 13 centimeters actually means to the top of this semicircle, would make more sense. Okay, so the height there is 13 centimeters. In other words, the height of the trapezoid is 7 centimeters. Just subtracting the two, 13 minus 6. Okay, so we need that for our formula as well. So let's go back here. So we've said the height of the trapezoid is 7. The side lengths are 3 and 12. Divided by 2. Okay. With your calculator, simplifying that should give you 56.547 plus 52.5, which tells us the area of this composite shape is approximately 109 centimeters squared. The next example is a word problem. It says a carpet cleaning company advertised a 3-room special up to a maximum of 56 square yards at $119.95. Mel is planning to have the carpet in 3 bedrooms cleaned, and the dimensions of those 3 rooms are given. And we are asked to figure out whether Mel qualifies for this special. In other words, we need to figure out if her square footage is less than 56 square yards. So in order to do that, let's figure out what the total area of these rooms would be. We'll start by finding the area in square feet, since the dimensions are given in square feet. So we've got 3 rooms here. One room is 8.5 by 11 feet. The second room is 13 by 15. And the last room is 14 by 15. Okay, so the area of each room is 93.5 plus 195 plus 210 for a total of 498.5 square feet. Now, we need to convert this to square yards because the maximum square footage, square yards for the special is 56. So we need to figure out, is 498.5 square feet less than 56 square yards? If it is, then she qualifies for the special. Let's remember that in a yard there are 3 feet. So if we are looking at a square yard, a square yard would be 3 feet long on each side, which tells us that 1 square yard is equal to 9 square feet. Therefore, if we want to convert 498.5 square feet to yards, we can do that by dividing by 9. So we're going to convert to square yards. And we're going to do that by dividing by 9. 498.5 divided by 9 is approximately 55.4. So we can say, therefore, yes, now qualifies for the special. Because the total area of her 3 rooms is less than 56 square yards. So in this example, we chose to to find the area in square feet first, and then converted the square feet into square yards. An alternative would be to have converted the dimensions of the rooms into yards first and then find the area. And I'm going to use that type of approach with the next example to show you the alternative. Okay, for the most part, this approach actually does work better. In the last question, it was fine because converting from square feet to square yards is quite easy, but it's not so easy when you're converting from meters to square feet as we are in this particular question. So let's have a look at the example. It says Ron's driveway is 15 meters long and 6 meters wide. He plans to replace the asphalt he currently has with interlocking stone, and stone is sold by the square foot. How many square feet must he order? So his driveway is 15 meters long and 6 meters wide. Let's begin by converting each of those dimensions to feet. So off to the side here, let's remember 1 meter is the same as 1.0936 yards from your conversion charts. And in a yard, there are 3 feet. So if we multiply 1.0936 by 3 feet, we can convert 1 meter to 3.28 feet. So then his driveway, if we want to convert this into feet, we will multiply each of these dimensions, by 3.28. So the dimensions of his driveway are 19.68 feet by 49.2 feet. Now we can find the area, which is found by multiplying length times width. So 19.68 times 49.2 gives us approximately 968.3. And that is square feet, because of course we had already converted the dimensions to feet, so the area will be given in terms of square feet. Now remember, we're talking about ordering stone here, and so we need to always round up this so that we don't run out. So we want to round this up. Let's make a little note to 969, but probably makes more sense to round up to 970. So therefore, he should order 970 square feet of stone. And that completes your lesson for today.